A few other things to keep in mind as you study the process. Look at the input stream. What are we supplying, right? Ask yourself, what is the energy source? Can we, in comparison to what we're doing now, can we use a source that, can we use a process or design the process that uses less energy, or a more benign source of energy? Maybe you're using coal-fired energy. Can we use solar energy or tidal energy and so forth? What about what kinds of chemicals are used to make the process happen? Are they hazardous? If they are, can we substitute this? And again, are you using virgin materials or recycled materials? So this is sort of like a checklist to apply to the inputs to a process. Now on the output side, these are a few things you can ask. So what goes out? Are there any chemical byproducts that are produced? If so, can we redesign the process to make sure that there are no byproducts that are produced, or that the byproduct can be used in-house? Like, if you have heat used in a process, and as a process is getting done, is the heat lost because you have poor insulation, or do you have good insulation that saves and traps the heat? Is the outgoing hot water or steam, after it's spent in a steam turbine, are we just releasing it, or are we using it to reheat fresh water coming in, or reheating nearby offices? Looking at the mechanical and relational arrangements, how the process is laid out on the floor. What kind of process is this? It's just batch or continuous process. So some of you may not know the difference between batch and continuous process. Certain things are manufactured a few parts at a time, at the end of which we stop, we do some maintenance and rerun another batch. For example, automobiles are made in batches of 200 cars, or 2,000 cars, or your cell phones are made in batches. On the other hand, when we manufacture things like crude petroleum, or you're making steel, it's a continuous process. It doesn't stop. Once you start it, it goes on for months and years until it's time to take the system down for rehauling. With automotive manufacturing, at the end of the day, you can shut the plant and go home. You can't do that with these others. So they are either batch, which means you make a certain lot. It's like baking cake, right, or muffins. The baker makes 200 muffins a day. It's called a batch process. So if it is a batch process, you have to start and stop, start and stop. When you start a process from cold, you have to ask yourself, how much energy and materials do I need to do that startup? Usually the startup needs more. Are the process located close to one another? Is the incoming material close to the process that's going to use it? Are they far apart, which will involve a lot of unnecessary transportation? So just looking at how things are laid out. And if a substantial byproduct stream is generated, is there a nearby process that can use this byproduct? Again, these are all just checklists. If you are doing stuff like painting, spray painting, electroplating, ask yourself, are we releasing volatile organic compounds? These are, what it is some products will keep releasing stuff in the air, like paints and varnishes. Even after you're painted, you get the paint smell, right? And it's, hopefully you don't like varnish or paint smell. I know a few people who seem kinda, it's crazy, but addicted. Not a good thing. You're not supposed to be inhaling them. Walk away. So we ask ourselves, are we doing anything that releases volatile organic compounds? It can cause allergy, rashes. It can cause you to tear up. Various kinds of respiratory problem. And are we releasing working oils to the water? These are all, again, sources of pollution. So guidelines. If you are dealing with a process at the micro scale level, there are the so-called principles of green chemistry that you can use. I'm going to just go over a few important ones. So these are at the molecular level, right? So we have various kinds of chemical reactions. We have addition reaction, we have reduction reaction, and we have substitution. Let me make sure I got this right. Addition, displacement, and elimination. Addition means A and B react to form AB. So everything that comes in becomes the product. In the case of displacement, A reacts with a molecule called BC, so making AB, but then C is released. Or you can have AB and CD reacting, where AC is the product, but you also make BD, right? So, the first is called an addition reaction. Then you have displacement, and you have elimination. So we prefer addition reaction because no byproduct is created. If you're using synthetic technology, you want to make sure that the process is designed to maintain the efficacy of the process, but ensuring that while using and generating substances that produce little, cause little or no toxicity. Again, and this is quoted from before, feedstock, meaning input material from renewable sources are better than those from non-renewables, and auxiliary stuff like cleaning agents, solvents, etc. Try to see if you can get away without using them, because they are always problematic. And if it is meso scale, here are certain things you can broadly look at. Can you minimize consumption of inputs like materials, energy, and water? Minimize the number of cleaning processes. Most, if you can get away without cleaning, then that's great, but most will require some cleaning. Fewer the cleaning, the better. Minimize secondary processes like coating, surface coating, and then match waste streams with inputs. So waste from X becomes input for Y. Eliminate redundant processes. Capture residue for reuse, like fly ash can be used in manufacture of cement. And capture waste. If you must make waste, make sure you capture them and you treat them before they are disposed, so that they are not harmful to the environment. So in this chapter, basically what we are looking is process design. It's like baking that makes the cake. So what can you do during the baking process to make sure that you're being environmental friendly? And this consists in preventing pollution, minimizing the use of scarce resources, and designing the whole process, not just from within the factory walls perspective, but the entire life cycle, all the way from cradle to the grave. So that's the theme of the class. We'll see you in the next class.